Hey guys, this is your trainer Anirudh Chhillar. So I'm back with another video of EIGRP. I hope you're learning in a good way and in good pace. Let's go.
Tell me. So I hope that now you have understood that if you change your AD value for summary address, then there can be a big problem. Your entire network, your network can even, of course, there will be a big problem if you do some misconfiguration along with your summarization. So this is that how can you see that, okay, in EIGRP also there can be a routing loop if you do not configure your AD value as 5 for your summary address. Have you understood it or not? Fine. Let's move again on R6 and let's change its AD value. Make it once again 5. And because this time you have configured its AD value as 5 once again, so you will see that it will install that prefix, that summary address towards null 0 in its local routing table. And now we can move on R1. Still that loopback is down 90.1.1.1, right? But this time, because it is receiving this summary address coming from R6, so it will advertise, it will transmit data in the direction of R6. And because R6 do not have any individual prefix for reaching 90.1.1.0/24 network, right? But it was having a summary address going towards, pointing out null interface. So this time R6 have transmitted all this traffic towards null interface and it has been dropped. That is why there is no routing loop now. So I hope that you have understood that in EIGRP, why do we have AD value as 5 for summary address, right? And why do we have this feature in EIGRP that wherever you will configure summarization, it will always put that entry towards null 0 interface as well. Because if that entry is not there, then in that case there can be a routing loop, and we have seen it. We saw that how can a routing loop occur in your network if your routers do not put entry towards null 0 interface in their routing table. Have you understood it or not? Tell me. Fine. So this is that how can we modify AD value for summary address and what will be an impact. AD value? No.
नहीं जो समरी रूट है जैसे हम नल 0 के साथ होता है नल 1 के साथ भी हो सकता है
नहीं, कभी नहीं होता. नल 1 इंटरफेस होता ही नहीं है. नल 0 ही होता है, सिर्फ नल 0. Guys, have you understood all these topics till now? Like summarization and all, the use of leak map, Puskin. Vinit, any problem? Sure. Fine. Let's again move on R6 and remove this summary address from here. And again for R1, its best part to reach all these 90s prefixes, 90s subnetworks will become via R6. Fine, let it be. But finally, now I have taught you that how to configure summarization and how to manipulate the things with using summarization. Fine. My final question is to all of you now. If we are having this type of design, this is R1,
दो समरी रूट है
this is R2, wait, this is R2, right? This is R3. Now on R2 you are having a default route in the direction of R1. Behind R1 you are having a prefix which is 10.1.0/24. You understand? But you didn't advertise this prefix in EIGRP. Are you getting my point or not? Hello? But on R2 you have configured a default route in the direction of R1. Fine. Behind R2 you are having some prefixes. Fine. Now between R2 and R3 now EIGRP is running. Between R2 and R3, let's assume that EIGRP is running, and you decided to advertise all these prefixes into EIGRP so that R3 can learn them. And then finally you said that okay, let's configure summary address for these two prefixes, because that 10.1.0 is not coming from R1 to R2. That is why for R2 it is not possible to advertise that 10.1.1.0/24 in the direction of R3. So finally you decided that okay, let's do one thing, on this interface configure summary address, and it is 10.1.0.0/ and we can see here that 10.1.1.0 is also part of this summary address. Have you understood it or not? So because R2 was not having this 10.1.0/24, but still you can see that this 10.1.0 subnetwork have become the part of this summary address, right? So it is advertising the summary address in the direction of R3 now. So from R3 now, behind R3 you are having a user which wants to communicate with 10.1.1. So R3 is having a summary address. R3 will forward this packet in the direction of R2. Now R2 will perform routing lookup, and R2 is having a default route to reach R1, but along with this summary address it will be having this entry towards null 0 based on longest prefix match. Based on longest prefix match, this R2 will forward your packets towards null 0 interface. Is not it? Hello? However, it is having a default route by which it can reach R1's lane, but still R2 will drop your packets based on longest prefix match. Why will it use this default route to reach 10.1.0? Because in another hand it is already having this summary address towards null 0 interface. So based on routing lookup, it will take decision to forward your packets towards null 0 interface. Is not it? Now in this kind of scenario you will require to restrict EIGRP to do not install this summary address towards null 0 interface in its local routing table. So what will you do in that case? You will configure its AD value as 255. You will require to configure its AD value as 255 so that this R2 will not create this entry towards null 0 interface in its local routing table, and then it will be possible for R2 to perform routing lookup, and it will be possible for this router to utilize this default route which is going in the direction of R1. So I hope that you have understood it, that in which conditions we will require to restrict EIGRP to do not install this summary address in its local routing table towards null 0 interface. Have you understood it or not completely? Because there will be some few cases in which definitely you will require to restrict your EIGRP to do not install this prefix, this summary address towards null 0 interface. Tell me.
We can getting down to R1 for that particular
In that case, there will not be any problem. In that case, you will not require to remove this entry from its routing table, this null entry, because based on longest prefix match, it will take decision and it will forward your packets in the direction of R1. If you are having this prefix available in the routing table of R2 on /24. Understood? Fine. So this is all about summarization now. we don't have anything left in summarization for EIGRP now. There is no single command to configure. Our total uses of leak map, you can simply leak your prefixes if it is required. Our total use of AD value 5. I have also told you in which conditions you will require to change it. So finally, let's go for route filtering. And again, in EIGRP, you can perform route filtering with using only one thing, which is only and only distribute list. But within this distribute list, you can use like standard ACL, extended ACL, prefix list. But here you are also having another method to perform route filtering in EIGRP, which is route map. In RIP, it was not possible to perform route filtering with using route map, but in EIGRP definitely you can perform route filtering with using route map. So I will start it from standard ACL, then I'll go for extended ACL, and then I'll go for prefix list as well. Have I taught you in EIGRP that how to configure static neighbor? Hello? Have I taught you that how to configure static neighbor in EIGRP? Please go through it. Do one thing before going to perform route filtering. Let's configure static neighbors in EIGRP. As I said that in EIGRP you can also configure static neighbor, and then after configuring your neighbor statically, it will send all types of messages as unicast messages, right? It will not use any multicast address at all, but after configuring your neighbor statically. And in EIGRP it is also mandatory to configure your neighbor statically on both ends. If you have configured it on one end, then configure it on both ends. If you do not configure your neighbor statically on both ends, till that your neighborship will not come up in EIGRP. Even it was one of the requirement to form neighborship in between two routers, right? So again, I'm gonna to configure your neighbors statically here in this multi-access network, in which we are having these three routers, R6, R1 and R4. I will configure this R1 as a hub, and I will take this R6 and R4 as a spoke. So again, I'm gonna to build hub and spoke topology by defining your neighbors statically here. Have you understood it or not? Hey guys, again your topology will be same as like we configured in RIP. Like I'm gonna to configure this R1 as a hub, and then R4 and R6 I'll be using them as a spoke. So R1 will be having neighborship with R4, and then also it will be having neighborship with R6 as well. So let's configure it now. So start it from R6. Router EIGRP 100, neighbor is what? 150.1.146.1, and then in EIGRP it is also mandatory to specify your exit interface, which is fast Ethernet 0/0, because this neighbor R1 is reachable from R6 out from FA 0/0 only. Sorry, it is 155. That will break neighborship. Let's move on. R4 now. Router EIGRP 100. And configure your neighbor. And exit interface is FA 0/1. Router EIGRP 100 neighbor. As well as you see that it has formed neighborship with 6, but it have not formed neighborship with R4 because I think I shut down its link, so I have to say no shutdown. You will see that now R4 will form neighborship with R1 only, but this time it have not formed neighborship with R6. Have it formed neighborship with R6 now? No, it does not have. Even you do one thing, move on R4. You can also shut down its serial 0 by 1, so that it will not be possible for R4 to receive any prefix coming from R5. Move on R4. Swipe it out. It's not receiving, it's receiving only the lane of R1. It's receiving only the lane of R1, and it is happening due to split horizon. You know why? Because R6, R1, for R1, the best path to reach all of them is via R6, because if R1 goes via R3, then it is having only serial link, and its bandwidth is 1.544 Mbps and also delays 20,000 microseconds. So for R1 to reach all other prefixes, its best path is via R6 only. So because R1 is receiving all updates coming from R6 on FA0 by 0, that is why it is not possible for R1 to transmit all these updates out from FA0 by 0 itself, due to a split horizon. That is why for R4 it is not possible to have any prefix available inside its own routing table. There is no route available in the routing table of R4 now, due to split horizon only. You can check it once again. So to solve this problem, what will you do? You can configure, you can disable this split horizon on R1's FA0 by 0. Let me go there on R1, and you do one thing. Say no IP split horizon EIGRP, then its AS number was 100. And this time on R4 you must have all routes available. Now all routes are coming from R1, is not it? Even if you try to trace route the loopback of R6, you are going via R1 and then coming back to, and this problem was not existing in case of RIP. Do you remember? Do you remember that in RIP it was not changing its next hop address automatically after disabling split horizon, is not it? But in EIGRP it will definitely change its next hop address. In EIGRP it will definitely change its next hop address, because by default in EIGRP there is a command next hop self which is automatically configured. In EIGRP, next hop self command is by default configured. It is a built-in feature of EIGRP. That is why when updates are coming to R1 and it is sending out from R1's FA0 by 0 itself in the direction of R4, so for R4 its next hop address is coming as R1's address, and that is not good, because we know very well that R4 can directly reach R6, but it is going to R1 and then coming back to R6. So overall delay will be increased. Are you getting my point or not? This is the problem with EIGRP. One problem we solved by disabling split horizon, because previously R4 was not receiving any single prefix from R1, right? But this time R4 have learned all prefixes coming from R1, but the problem is next hop has been changed by hub. Hub is configuring its own address as next hop address. That's the problem, because whenever you will go from R4 to R6, you have to go through the hub. You have to go through the R1. How can we solve this problem now? By disabling this next hop self feature. And in EIGRP it is possible to disable this feature. So you do one thing, move on R1 now, and on its FA0 by 0 say no IP next hop self. Sorry, EIGRP 100. Once you will configure this command now, so whenever this R1 will send all those updates out from FA0 by 0 which were received on this interface itself, is not going to change their next hop addresses. So this time whenever this R4 will receive these all prefixes, their next hop will still be 146.6 this time. As you can see now it is 146.6. So if you trace route now 150.1.6.6, you will directly go in the direction of R6 itself. You will not require to traverse R1 now. Previously it was mandatory for the users, for the lane users of R4 to traverse R1 whenever they were sending traffic to any other user in this diagram, like to the lane user of R6, to the lane user of R5, whatever it is, right? Every time it was required for R4 to traverse R1, to traverse hub, but this time it is not longer required, just due to, just because of next hop address. Have you understood it or not? Because whenever it would perform routing lookup in its routing table, its next hop address would be 146.6. So now it will definitely forward your packets in the direction of R6 only, not in the direction of R1. So I hope that now you have understood the use of no next hop self command in EIGRP, and also you must be able to understand the uses of command no split horizon as well. I hope that you have understood the concept of split horizon in EIGRP as well as the concept of next hop self. Is there any problem related to split horizon and next hop self command? Please let me know if you are having any problem with it, with any one of the command in between these two. Ask me if you are having any query related to it. Understood it completely? That what is the role of split horizon? What is the role of next hop self command? Fine. After going through these things, that what is the role of split horizon and what is the role of no next hop self, and remember, I'll be using all these features of EIGRP during DMVPN, because in DMVPN, if you go to configure, if you configure EIGRP over DMVPN, you can't perform anything without using all these commands like no split horizon or no next hop self, whatever it is, right? These commands will always be required during the configuration of EIGRP over DMVPN. That's why I have covered all these topics here. Even though we are not going to configure the EIGRP over DMVPN right now, but still now we have at least understood that what is the uses of next hop self command and also what is the uses of no split horizon. Fine. Next is now route filtering. So do one thing on R4, serial 0 by 1, no shutdown, no router EIGRP 100. Say once again router EIGRP 100. Node of summary network 155.1.0.0, network 150.1.0.0. On R3, sorry, not on R3, on R1. No. First of all, remove it. On R6 as well. Now please let me know if you are having any problem related to any topic which we covered till now. Otherwise, now I'm going to start your route filtering. Tell me. Then let's go for route filtering now.
Route filtering.
What? So this is, see, access list is there. Do show run pipe section router EIGRP. I think I have done. I'm having some initial configuration here or some pre-configuration, so I have to remove it first and then. Nothing. No access list. Is there any ACL now? No. So let me know, what do you want to filter out from its routing table now? All odds, all events, procedure is same as RIP. The uses of distribute list is same as RIP. Like you can use distribute list in both directions, in inbound as well as in outbound direction too. But remember that EIGRP is a distance vector routing protocol, so it will advertise only and only best routes information towards its neighbor. What does it mean? That if you filter some routes in outbound direction from R5, so it means they will not be available on switch 2, and if they are not available on switch 2, it means definitely they will also not be available on switch 4. So let's do one thing, move on R5 and with the help of standard ACL filter all 90s prefixes in outbound direction going towards switch 2. So move on R5, success list to 1. Let me check whether it is having any existing ACL or not. So it is already there, right? So access list 5, deny 90.1.0.0 0.0.7.245 and then say access list 5 permit. You have to permit all others, and then say router EIGRP 100 distribute list. Then your standard ACL number was 5. In which direction? Out. Now if you configure this command over here only, then remember that it will be applied for all interfaces, right, of this device in their outbound direction. But if you are apply it only on FA0/0, then just call your FA0/0 only. So this time this distribute list will be applicable only for this interface for its outgoing updates only. So whenever it will advertise any 90s prefix out from this interface, it will filter them. Show IP route. However, this R5 will keep them inside its own routing table because it will keep to receive them. It will still receive them from R3 as well as from R4, but it is not going to advertise them in the direction of switch 2 now. So if you move on switch 2 this time, show IP route, let me show you. Is it there? And if switch 2 is not having those 90s prefixes, then of course they will not be available in the routing table of switch 4 as well. So it has proved that EIGRP will advertise only and only best path information towards its neighbors. And also it has proved that we can also configure distribute list in outbound direction too. So move on R5 once again, go to its FA0/0 and remove. Sorry, we have to move inside router mode, right? Router EIGRP 100 and then remove this command. And again you will see that all these 90s prefixes will be available in the routing table of switch 2 as well as switch 4. So now if you move on switch 4, if you check its routing table, you must get them. So in this way you can configure distribute list with using standard ACL. And then also you can configure standard, you can also perform route filtering with using extended ACL. And I hope that I have already explained to you that why do we require to configure route filtering with using extended ACL. So I'm not again gonna to explain all those things which we explained you during RIP. That's why I said that route filtering will not take so long time in EIGRP, because now I'm not required to explain you that how standard ACL works, how extended ACL works, in which conditions you will apply extended ACL, in which conditions you will apply prefix list, right? So we have already covered all these things. So this time I'm just gonna to implement all these things. Fine. So on switch 4, all these prefixes are coming, and this time I will filter out all these 150s prefixes coming from its neighbor switch 2 with using extended ACL. So you do one thing, access list 101 deny when these prefixes are coming from a host which is 108.8, because I want to filter them whenever they are coming, when they are coming from this particular host. Then it will ask me about destination addresses. In destination addresses you will specify to whom you wanna filter out. So 150.1.0.0 then 0.0. I think 15 or what? Would it be enough? Hello? Because your prefixes are from 1 to 9 or 10. However, 10 is directly connected, but you are having 1 to 9. So what would be your range? What would be your subnet mask to call all of them? It will be 245.245.240.0. And if you are having 240, in that case your wildcard mask will become .15, right? So this time say access list 101 permit, IP, any. When source is any, destination is also any. I mean, all other prefixes must be allowed. So you do one thing, router EIGRP 100 distribute list 101 in which direction? In on which interface? Because switch 4 is receiving all of them on FA0 by 0. So on switch 4, apply it on FA0 by 0. And this time if you say show IP protocols, it will show you that you have configured, you have filtered your interface for EIGRP updates. I mean, you have filtered all those prefixes on this interface which matches with this ACL 101. So definitely this time you must not receive any prefix which belongs to 150's range. Is there? However, it is still having 150.1.10.0, but it is directly connected. It is not received from that neighbor. So this time from this neighbor it have stopped to receive any prefix coming from the range of 150's subnetwork, 150's networks. It's not it, because we have filtered all of them. If you are having any problem, please let me know with extended ACL. However, you will be configuring this filtering with using extended ACL in case of multi-access networks only. Like if you are receiving your routes from multiple neighbors on a single interface, right? Just like I explained in RIP as well, right? So in that case, in those conditions, you will require to configure extended ACL. Now next is what? Prefix list. Router EIGRP 100, just remove it, and this time I'm gonna use prefix list. So which route you wanna perform? You wanna filter out from its routing table. So this time you will see that all of them are available here, 150's, 155 and all 90's prefixes. So which route you wanna filter out from its routing table with using prefix list? Tell me. 90's prefix. So just configure one prefix list here, IP prefix list CCIE deny 90.1.0.0/21 greater than, because all of them are coming on /24 itself, so you will say greater than 24, less than is also equal to 24. Say IP prefix list CCIE permit 000/0 less than equal to. Any problem? Router EIGRP 100 distribute list prefix list, and that prefix list name was, then its direction, because all these prefixes are incoming prefixes, right? You can say in. This time it will be applied for all interfaces. See, and you must not receive any single prefix belongs to 90's range. Let me show you. So there is no difference in route filtering with using standard ACL, extended ACL or prefix list in between RIP and EIGRP. Have you understood it or not? Even you could also use that gateway keyword here. Router EIGRP 100 distribute list gateway and then your prefix list. But here you will specify only and only gateway. You can also call this gateway after prefix. Let's say I said prefix was, tell me CCIE, and then also you can call your gateway now. So that these prefixes will get filtered from these specific gateways only, which you have defined in this next prefix list. If you are using prefix list with gateway keyword, you will require to create two different prefix lists now. In one prefix list, you will specify that which routes are permitted and which routes are denied. In another prefix list, you will specify that which gateway is allowed, which gateway is denied, and which gateway is permitted. It is somehow it is same as extended ACL, but it is more granular than extended ACL, because with using prefix list you can filter routes like all those prefixes which belongs to this summary address coming on prefix length /27 to 29 or whatever it is, right? I'm not going to explain all those things once again here related to prefix list, that okay, this is the reason so that you are having prefix list, this is the reason so that you will implement prefix list to perform route filtering rather than implementing standard ACL or extended ACL. So I hope that now you people have your mindset that where to implement standard ACL, where to use extended ACL, and where to use prefix list. Are you okay with all these explanation? Fine. Finally, route map. Do show or remove this command from here now. Show IP protocols. I have removed everything from here now. Show IP route. Now all routes must be available here in its routing table. Finally, it is route map.
So that's the end of today's video, guys. So we'll be coming back with few more videos of EIGRP. I hope you learned something new today. So if you like this video, please subscribe my channel. That's @ARC_tutorial. Thank you so much, guys. See you later.